Hello everyone, this is Dr. R. Manchula, Assistant Professor, Department of Chemistry, SRM, Madurai College for Engineering and Technology. In this video, I am going to discuss about zeolite process under water treatment. Water is the most important component for the existence of life. If the water contains impurities and salts, then it is unfit for domestic purpose. So, we need to remove the impurities and suspended salts before using it. Water treatment is nothing but it is the process of removing the impurities from the water. It is otherwise called water conditioning. It is classified into two types. One is external conditioning, another one is internal conditioning. Zeolite process is one of the external conditioning method. In this method, the suspended salts are removed by adding chemical compounds externally to the water. After that process, the treated water is used for domestic purpose. Zeolites are naturally occurring mineral under the earth. It has hydrated sodium aluminosilicate. Its chemical structure is Na2O, Al2O3, X SiO2, YH2O. In this chemical form, the silica composition X varies from 2 to 10. Water composition Y varies from 2 to 6. It is generally represented by Na2Ze. It has loosely bound sodium ions in its structure and capable of exchanging reversibly its sodium ions for harness producing ions like calcium and magnesium in water. There are two types of zeolite. One is natural zeolite, another one is synthetic zeolite. The natural zeolites are green in color, which cannot be used in the treatment because it has non-porous structure. The synthetic zeolite form is called permutate or boiling stone. It is porous and gel-like structure and it can be used in the treatment very easily. They are prepared by heating together china clay, feldspar and soda ash. Synthetic zeolites possess higher exchange capacity per unit weight than the natural zeolite. This is the block diagram for the zeolite process. It contains four components: a column, inlet, outlet and NaCl tank. First, a column is packed with zeolite bed. In the top, it has an inlet pipe for sending the raw water. In the bottom, it has an outlet for collecting the treated water. A tank having sodium chloride solution is connected to a side of the column. Initially, the water is allowed to pass through the sodium zeolite bed. During the flow, the harness causing ions are retained by the zeolite bed as calcium zeolite and magnesium zeolite, while the outgoing water contains sodium salts only. That is called soft water. These are the exchanging reactions take place in this zeolite treatment. When the hard water is percolated at a specific rate through the bed of zeolite, it exchanges its sodium ions with calcium and magnesium ions of hard water. Here we are having few exchanging reactions happening in the zeolite bed. First one is the removal of temporary harness producing salts. The sodium ion of zeolite is exchanged with calcium of calcium bicarbonate salt and forming calcium zeolite as product which kept in the zeolite bed itself. Similarly, the magnesium of magnesium bicarbonate is exchanged with sodium ion of sodium zeolite. The second one is the removal of permanent harness producing salts. The sodium ion of zeolite is exchanged with calcium of calcium sulfate salt, forming calcium zeolite as product which kept in the zeolite bed. Similarly, the magnesium of magnesium chloride is exchanged with sodium of sodium zeolite. So after the treatment, we get treated water, and the zeolite bed is having sodium ion and calcium ion. This is the regeneration of zeolite. When all sodium ions from the zeolite bed get exhausted, it can be regenerated by passing the sodium chloride solution. At this stage, the supply of hard water is stopped and exhausted zeolite is reclaimed by treating the bed with concentrated sodium chloride solution. Now, the reverse of exchanging reactions take place. That means the calcium of calcium zeolite and magnesium of magnesium zeolite are replaced by sodium of sodium chloride solution. The calcium chloride and magnesium chloride are formed as byproduct which are removed by the outlet. After this step, the zeolite bed is regenerated and ready for further treatment process. These are the limitations of zeolite process. First one, if the water is turbid, then the turbidity causing particle clogs the zeolite pores in the bed and making it inactive, so that the turbid water cannot be treated. The second one, the ions such as manganese and ferrous forms a stable complex with zeolite, which cannot be regenerated easily, as both metal ions bind strongly and irreversibly to the zeolite structure. So, the water contains these kind of ions cannot be treated. The third one is the acid water cannot be treated. The acid will hydrolyze the SiO2, forming silicic acid. So, any acid present in water should go down before admitting the water to the zeolite plant. These are the advantages of zeolite process. The residual hardness of treated water is about 1 to 2 ppm. The equipment is small, compact and easy to handle. The time required for the softening of water is small and it is a fast process. No sludge formation in this process, so it is a clean process. The zeolite can be regenerated very easily using brine solution. Let us see about the disadvantages of zeolite process. This treatment replaces only calcium and magnesium ions with sodium and not replacing other ions. So, the zeolite process produces soft water only. Also, this soft water contains more sodium salts than in lime soda process. It causes boiler trouble sometimes. When sodium carbonate hydrolyzes to give sodium hydroxide, it also causes caustic embrittlement. Hope you understand about the zeolite process completely. Thank you for watching my video.